This is another example where we are given a logic circuit and we have to come up with its truth table and Boolean expression. Like I have explained in my previous video, I am going to label the intermediate outputs. So we have two inputs here, A and B, one output X, and I'm going to label the outputs from each internal logic gate. So I'm going to start from here, C, D, E, and F. So now I am going to create the truth table. So we have the two inputs, A and B, and then we have C, D, E, F, and X. The inputs combinations are the usual 0, 0, 0, 1, 1, 0, and 1, 1. And we can start with this logic gate C, column C. C is a NOT gate and it's the NOT of A. So it's basically the opposite of A. So here we have A is 0. Here it comes 1, 1, 0, and 0. Here we have D. D is also a NOT gate. It's the NOT of B. So D is the opposite of B. So 1, 0, 1, 0. Now here we have E, column E. E is the output of an AND gate and is the output of C and D. So we have to AND together these two columns. Let's start with the first row, 1 and 1. Since it's an AND gate gives us a 1 whenever all inputs are 1. So 1 and 1 gives us a 1. 1 and 0, since we have a 0, it will give us a 0. The same here, 0 and 1, it will give us a 0. And here, 0 and 0, it will give us a 0 as well. Now we have the last internal gate, which is F. And F is basically the AND of A and B. So we have to focus on A and B here and do the AND result in column F. 0 and 0 gives us a 0 because there's a 0. The same here, 0 and 1. 1 and 0 gives us a 0 as well. But here, 1 and 1, since both inputs are 1, F will be 1. Now, the last gate is the gate that will give us the final output. So X is the final output. And X is OR, this is an OR gate, of E and F. Therefore, we have to focus on these two columns. So we have 1 or 0. Since there is a 1, the output will be 1. Then we have 0 or 0. The OR gate will give us a 0 if both inputs are 0. The same here, another 0 or 0. And here we have 0 or 1. There is a 1, so it will give us a 1. And therefore, this is the final result of this logic circuit. Now, if we have to write down the Boolean expression, the best way is to take a pencil and write down the Boolean expression for each logic gate. So here we have this, which is NOT of A. So here we have A NOT. Here we have NOT of B. So this is B NOT. This one, E, is the AND gate of this and this, but this is A naught and this one B naught. F is another AND gate. It's the AND of this, which is A, and of this, which is B. So A and B. To get the final result, the final output here, this is an OR, but it's the OR of this. You have to always follow the wire. So A naught and B naught, or this, A or B. Remember that according to the order of precedence, the AND has a higher order of precedence than the OR. Therefore, there's no need to write any brackets. So the final answer is X equals that one. Not A and not B, or A and B.